All right, today we're going to be going over migrating from Datadog to Checkly. We're going to be looking at some of the technical differences, some of the pricing considerations. Myself, Dan Giordano, I'll be running through some slides, joined by our head of solutions, Giovanni Rago, who will be going through a demo and showing you how Checkly kind of does similar things to Datadog at a faster clip, better reliability, and a cheaper cost. For the most part, we will be focusing on showing off the Checkly platform today, but it's in consideration of moving from a tool like Datadog. So why do teams migrate from Datadog today? Datadog is a great tool that's built for operations teams that have somewhat of an infinite budget. But we do see engineering teams moving to us, and they primarily are coming for three reasons. Affordability, trying to run synthetics and uptime monitoring at scale can be extremely expensive on the Datadog platform. Modern automation, lack of support for Playwright or other open source scripting frameworks, or generally code as well. And then a better dev experience. So very similar, but lack of TS constructs, lack of version control, lack of monitoring as code that we'll go through today is why teams are looking at Checkly moving off Datadog. And that's because Checkly solves these application reliability challenges for modern dev teams. So Checkly pioneered monitoring as code, which brings your entire reliability setup from detection to alerts and status pages, all as code, which we'll look at. We have native Playwright support. So we have full support for the Playwright framework to run in production. So you can code even the most complex situations, most complex user flows that maybe touch multiple authentication systems, maybe have API calls inside them. We really allow for a large amount of flexibility because of that. We've also unified testing and monitoring even more so than Datadog for the developer. So combining running your end-to-end tests with your monitoring as a single source. Everything can be done on Checkly using Playwright, using your API tests. You have your tests running in CI, those pass, then they get pushed to production, and you now have a completely unified workflow. We're also affordable at scale. Checkly is transparent consumption pricing that's easy to understand and affordable to scale with your growth. So we'll go through a couple different scenarios of what pricing might look like and how that might affect your consumption as well. But Checkly is your entire reliability stack delivered, again, headlessly as a coded platform. So coming from tests, Playwright tests that can be automatically migrated to monitors that have multi-step, maybe API requests, or maybe just an API test itself, or an uptime test that might go and measure uptime of just your web page. All of that configured as code here, as you can see. Alerts, how teams get alerted based on what threshold of the monitor fails, over what locations fail. Again, all of it can be kind of processed, written as code, and deployed with your entire setup. Same thing with status pages. We have status pages when things fail to alert your external customers, to alert maybe internal users. Again, you can build your status pages, configure what services should be shown on those status pages, all written as code, so you never have to click around or use a clunky UI for your reliability setup as an engineer. Why is monitoring as code? Why do we believe it's different? Why do we believe it's better? There's primary four reasons, and the third one we'll get into a little bit as well in the demo, but it's codified. So everything is written as code. We can use automation. We can use variables. We can reshare storage state. We can reshare any really snippet across our application code into our monitoring setup. So again, when we talk about scale, that's what we really mean. We can have variables, base URLs, all encoded, and it allows you to expand your monitoring very quickly. You can also reuse your monitoring scaffolding and things like building wrappers for your alert metric or for your alert setup, or metrics that you want to have a threshold set against. All of that can be rebuilt or built as a wrapper, reused for different teams, for different endpoints, for different monitors. Again, it allows teams to collaborate and scale more so than a UI-driven tool. Version control allows teams to be able to review code, audit code, understand when a new monitor went into production, when new code went into production, and make sure that they're matched up. This is one of the big things as we move quickly in modern engineering. Deploying an application state that's maybe not yet monitored because the operations team sits elsewhere. Checkly brings that entire workflow together and allows you to consistently push out monitoring coverage on top of new features that come out. And again, that's because it can come in the same Git repository, it can be reviewed, it can be used in the same workflow. And the last thing that monitoring this code allows Checkly to take advantage of over a tool like Datadog is the entire platform is completely AI ready today. So while we have error analysis inside the platform and we have some tooling, you can use any LLM-powered IDE like Claude Code or Cursor or Codex to literally write your entire reliability configuration for you. It can maintain it as you update your code. You can use Claude Code rules to have certain things and features be written as it deploys. They're just an endless amount of possibilities because we're written as text. So we have a couple of webinars that we've run on how you can use Claude Code or Cursor with the Checkly platform. But you can understand that once the LLM understands your interface, there's really no limit to what we can do. The things that you can manipulate and again manage in Checkly with the help of AI. Now let's talk about monitoring creation, and which is really the heart of what we'll be talking about today, since this is one of the big things with migration. So Datadog today has a record and replay tool for their browser tests. It's an extension. It's a powerful record and replay tool. It's great for non-devs, but as everybody went through with end-to-end testing and test automation. Record and replay tools all basically suffer from many of the same maladies. It's slow to build. It like tests at scale. So yes, you might get through a single test quicker, but as you build out an entire test suite, you'll constantly going through 80% of the same workflow, and then the end might be different, so you'll constantly be copying yourself. Again, when you need to maintain that test and change it, it's very slow to maintain, and that's probably the biggest fault of record and replay tools is maintainability as your code base changes, as your UI changes. Those will all have to be edited manually, and it's a very slow process. And then just on the technical side, there's often a lot of limitations around things in the DOM that may struggle with a record and replay tool, shadow DOM, single page applications that don't render new URLs and happen in modals. Again, all those things can really throw off record and replay tools. And there's no ability to have the flexibility that you as an engineer know code provides you. Checkly literally was born to solve that problem. So we use Playwright to power our synthetic monitoring. We also have constructs for other monitoring, but again, we'll talk about this here and then we'll go through the demo that will show you a couple of different ones. But it's fast, scalable, and incredibly reliable. It's the most popular testing framework today, again, for modern engineering teams. And it allows you to create your monitors in code, deploy them, and then again have the flexibility to use shared auth states, shared logins, shared maybe entitlement states of different users. And this is the natural way for engineering teams today that are using Playwright to test. You now can push this to production. So the entire idea that you are building these end-to-end tests in your pre-prod environments, running them in CI/CD, There's no need to duplicate that. We can push that to production and start to monitor globally from around the world with that same Playwright test. It gives you all the same flexibility that code gives you everywhere else. Playwright comes with powerful debugging that's in the Checkly platform. So all of your test results, all of your test runs will be available to debug, see what maybe failed, whether it's the test itself or whether it's the application, which will go through open telemetry tracing on the other side. So we have two types of tracing, kind of always did the test, was the monitor the problem or was the application the problem? Those two things we try to surface as quickly as possible to make it easy for you to resolve that problem. We also, because Playwright has CodeGen, it has a recorder that you can use. So again, because the platform is flexible and extensible and code-driven, any of the features of Playwright are now available for you to run in production on Checkly. So you can generate tests via CodeGen with a browser extension, or you can write code yourself in an IDE, or you can do both. And they all can help you quickly write your actually end-to-end synthetic tests. Here are just some of the Playwright features that Checkly supports that you can bring to your monitoring and reliability process. So things like intelligent auto weighting, so tests are less flaky. Again, CodeGen, which we just talked about. We support testing from or monitoring from multiple browsers, Chrome, Firefox, WebKit, mobile device emulation, screenshot and video recordings of each test run, visual regression testing, so actually comparing the screenshots from run to run, all sorts of things like timeouts and trace and network waterfalls. But it brings the power and maturity of the test automation landscape to our monitoring game. And it does it in a way that unifies both and allows us to not really need duplication and to, again, improve coverage without needing to actually add anything. Let's talk about pricing next, and of the different check types that we'll go through, and then we'll kind of go through, again, a demo of creation. So pricing breakdown, kind of three different vectors that we all can compare ourselves again. Datadog has two, we have three, actually creates a cheaper paradigm for us. But we look at pricing in kind of three different ways. Uptime monitors, which cover URL monitors, which are simple GET requests, so a simple GET on an API or a URL, TCP, or a heartbeat monitor. Those are what we call uptime monitors. API checks are complex API get, post, every command you can do, headers, anything that you would normally do with an API check. That is for both of us. We call those API checks. They also have multi-steps, so you can chain together requests. Each one of those chain requests is going to count as a check for both platforms. So it's equal pricing there. Browser checks, on the other hand, they are the UI against synthetic run against a full browser. Um, that for both of us, we call them browser checks. And you can see the pricing breakdown here. Uptime monitors for us, we're going to allow you to run 43,000 uptime checks within the month for about $1.45 a monitor. For API checks, it's 10,000 runs in the month of API checks for $1.80, and browser checks are $5. You can see on Datadog side, for API checks, that is really the check type that covers a lot of their targets. So things like the URL monitor that I was talking about before, for them, it would be an API check. They simply put everything into an HTTPS request and kind of go about it simplistically through that. It's very much the same UI UX, but again, for pricing for us, we do have a delineation, which again, in the real world, affects how much you might pay. So here, let's take a look at a scenario this is enterprise scale. It has three different vectors here. Talk about 50 UI scenarios, so 50 different end-to-end tests running at 5 locations every minute. Total runs, it's going to be 10 million runs every month. 200,000 API endpoints, running in 5 locations again every 30 seconds. So quite a bit more volume, also faster for your API endpoints that are more important. Total runs 86 million. And then the uptime monitors, which again, these would count as API runs on the Datadog side. For us, we're going to run them for 1 location every minute. You can see the breakdown here. Browser costs, API costs, and uptime costs are drastically cheaper on the Checkly platform, with a total savings here of just 61% across the entire bill. But browser costs for us are a huge savings, and then uptime cost is the biggest. We really, again, want to drive the idea of reliability and depth, where teams have maximum coverage across their application with uptime monitors. Then they have a second level of defense with APIs, and then they have their third level of defense with UI monitors. So it's very similar to the pyramid principle kind of test automation, but it creates a large coverage base that is scalable. Again, because monitoring is code, 500 uptime monitors you can create with a single script, with a variable, with data running through it to either scrape new maybe products that you have and automatically create a monitor for each URL, or do some type of another automation where, again, it doesn't have to be 500 different scripts. It could be one with variables. And then also affordability. So creating this reliability in depth system can be very expensive unless you have the cost metrics that allow you to build this. And this is what we allow. We're really trying to get broad coverage on the uptime and then come in and supplement where you have critical needs on the UI side. We want you to drive as much synthetic monitoring as you can. So you can see here we have a developer-driven modern reliability platform at a cheaper cost. And now we'll look at the platform itself and go through how would creating some of these checks look? How does maybe tracing look in the Checkly platform? And again, this is for people that are familiar with the Datadog platform. We want to give you a look at Checkly's platform at a mature stage. So I'll hand it over to Gio right now, and we can look through that.
Awesome. Thank you, Dan. Well, there's a lot of cool things that we can talk about tonight. Excited to be here. I'll need you, Dan, to sort of keep me on track because I'm gonna get carried away
No
with stuff for
problem.
sure. But
Just
gonna share my screen right now and yeah, and get started, right? So um yeah, there's a few things that I think we can look at, right? So before maybe we jump into, some interesting ways about, how we can take what we have in Datadog today and bring it onto Checkly. Maybe let's just kind of level set, right? So Dan, you've already sort of set the scene there in terms of, different types of checks, the different types of monitors and API versus uptime. Then we've got browser checks, there's Playwright checks, and so on. There's quite some things when we look at Checkly, right? In general, I would say if we want to have a, let's say, also, yeah, maybe more from the technical front, a very simple rule of thumb, right? The uptime monitors are really sort of the lower level, simpler, more straightforward kind of production monitors, right? So checking DNS, right? Verifying that a single URL is loading and so on, right? Just with some basic assertions on top. These are again kind of like the bread and butter of is it up or down, right? Checkly, we've historically started with you can see it from the label here, it says new. So um, we've started with synthetic checks, right? So when we want to go a little bit further up in the OC layers, right? And we're looking at API endpoints, complex API transactions, or complex browser transactions, right? Let's think about end user flows. Then this is another place where we really shine, right? And we're gonna take a look at like browser checks and Playwright check suites in a little bit more detail later in the webinar because I think that also factors into some really cool stuff that's been enabled just recently that can help folks migrate from an existing Datadog setup with synthetics, for example. Um, so Yeah. Um, Maybe actually, let me just start from again giving you a super quick look at our detection, communication, and resolution sort of triad here, right? And this is really the basics of synthetic. So I think you folks are pretty much caught up with it, right? But what we have running on Checkly, just like in Datadog synthetics, right, is different checks of different types. We've explored the types. We offer the possibility of running from global locations, right? Again, just exactly like you got it in Datadog, you can just easily add different global locations. And I'm showing everything through the UI right now. The UI is not the main way that folks drive Checkly at scale, right? I just want to sort of have a little bridge until we look into monitoring as code, right? So again, very, very short introduction here. A lot of our customers are also running private locations, which are containerized agents. Again, if you use Datadog, and wherever you can run those, right, you can actually run our runner. Sorry for the phrasing there, but you can essentially execute your checks, right, and then you just reporting back the results to Checkly. So you choose, of course, where you need to run from. Do you want to run round robin? Do you want to run in parallel? Do you have specific necessities here? Do you need to detect potentially regional outages and so on, right? These are all things that you and your team, if you have a proper strategy for testing and synthetics, will have down already, right? Of course, you can see here some color finally on our dashboard. We're getting some check failures on our demo web shop, right? In this case, which I always use to sort of illustrate the basic idea here. Our checkout procedure is failing, which, as you can imagine, on a web shop is well, it's pretty much a disaster, right? Here you can see a little bit of Playwright, right? Dan already introduced the tool, and then we'll keep diving into it as we look at migrating. But essentially, here our check is failing, right? We're running it every minute because again, a checkout procedure, buying stuff on our web shop is the absolute most important thing that a user can do, right? From our perspective, it's where we get our revenue from. And here, of course, we want to run the check at high frequency, right? And given Checkly's pricing model, right, and how we set things up for you, this is actually a place where you don't have to do that trade-off, right? You can actually start running checks at a pace that makes sense for you. The more often you run, or the higher the frequency, let's say, the earlier you catch the outage and the shorter the outage will be, right? There's another step to make the outage shorter, which is, resolution of the underlying issue. And we'll get to that right after we talk really quickly about the second step, which is communicate. Because once we detect an issue here, once the check starts failing, we still need to have a reliable way of involving folks, right? Who are these folks? Well, on one hand, you have, the people that actually need to dive into the issue. There's a lot of options here that we're not going to look at tonight in terms of alert setups, right? But this is where you, of course, set up your alert channels. You want to reach your people wherever they are. It might be, your on-call rotation on, say, Ops Genie or PagerDuty. You might have in parallel maybe a Slack channel where you're having a feed of everything that's failing, for example. This is sort of like the internal communication. And then there's also the possibility of setting up a status page, right? And the status page is pretty much something that we can build tightly coupled with our checks. So we can define different services here. This is a very simplistic example where I've only linked a single check. And we link a check to that service and we say, okay, if this check goes red, then we have an incident going on. And this, the status page needs to reflect that, right? Let's just jump into this super basic status page that I have here so you can see what I'm talking about. So communication really has these different angles, right? We want to, of course, internally reach out to, well, sometimes it's going to be some poor engineer at 3 a.m., right, that needs to just jump out of bed and figure things out. And there we provide, I think, very high quality information. Um, but on the other end, we might want to be transparent with our end users, right? At this level where we're just like, okay, there's an ongoing incident, you get updates automatically, and you know exactly what it affects, right? And we can have even some additional communication there in terms of incident management, right? And just like you see here. Okay, but without dwelling too much on that, we've covered detection, we've covered communication. Now we gotta cover resolution, right? So now that our poor engineer has gotten alerted, like woken out of bed, it's 3 a.m. You know, the web shop is pretty much down, right? How do we help them actually fix the underlying issue? Well, this is where the third point comes in, like resolution, and here is where things start to get very interesting, right? So Dan already showed you folks the playwright trace, right? So we see how things failed from the end user's perspective. Playwright gives us these great tools such as the playwright trace, which you're seeing here, which allows me not just to see exactly which step failed in the user transaction, it also allows me to dive into the network tab here, for example, just like you would in the dev tools. I mean, here we're using the Chrome dev tools under the hood, and we can see already there's an API check, or sorry, an API endpoint that's failing, right? Related to checkout. So we're already kind of zooming in to, or yeah, we're restricting, let's say, the field of possibilities for the underlying root cause here. Now, of course, one of the things that we're working on, and you can see the beta feature here, or the beta label here, is a root cause analysis AI feature, right? So this is where you pretty much use our AI assistant to bring all this information together and help you out, right? Again, maybe it's 3 a.m. in the morning, everything's looking very scary. We immediately get a readout on the user impact, right? Users are unable to complete purchases on the production web shop. This is where we're failing. This is the error message. And then there's a first guess at the root cause, right? Server-side failure. The post request to this endpoint, which is the one we just looked at, right? Returns a 500 error, which prevented the order completion and confirmation message from being shown. So, okay, this is not fixing the thing yet, but it's sort of already getting the right information, right? It's also helping us not to miss anything that's absolutely vital there. So, this is sort of still from the end user's perspective, right? Then we're doing something additional here, which some of you might be familiar with. I don't think there is anybody that's doing it exactly the same way as we are, but what we're doing is we're bringing that synthetics perspective together with tracing, right? With OTel tracing. So we're actually our web shop is instrumented with OTel, and its collector is sending us traces, right? So what we're doing here is essentially catching everything that has something to do with this user interaction, with this user transaction, right? With the checkout procedure that we just looked at, that is scripted in Playwright under the hood, and it's sort of connecting on the other side all of the traces that belong to this transaction. So here, for example, what I can see is at the bottom of this stack here, it's very interesting because, of course, we're looking at different services, right? This is a microservice-based application that we're monitoring. And here I can see the payment service is actually returning an error on charge, right? And this is actually the underlying issue already, right? So it's the payment microservice that is currently down, right? So here, what have we done essentially? We've brought together the outside in perspective and inside out to give you folks, to give whoever needs to remediate this the chance to do it faster. Because, or why is that important? Well, because the longer folks cannot buy from our web shop, the more revenue we're missing out on, right? So this is absolutely key. All right, so we've done the whole jazz, right? Detection, communication, resolution. We get that, Giovanni. It's synthetics. Okay, it's cool what you're doing with traces. It's cool what you're doing with AI. What about the monitoring as code bit that you've been teasing us with? Well, monitoring as code is pretty much enabling us to do everything that you've seen in the UI. Again, the UI here I'm using mainly for visual reference, but every single construct that you've seen, every type of check in all of its minute attributes and parameters, all of the different scripting bits, all of the status pages, dashboards, all that jazz, you can define and drive as code, right? Let's be a bit more specific. I've been playing a little bit with a couple of things here. So Um, what I have here is, of course, my editor, right? My VS Code. And what I'm looking at is a checkly config file that is, uh, well, plain JavaScript TypeScript file, right? It's just setting up everything so that we can actually declare different sort of, let me just uncomment this one, right? Different sort of checks, different sort of constructs, so that we actually, let me switch to something where we have, I want to show you two different ways of looking at this, maybe that could be interesting. Um, we're essentially able to specify every single bit of our config as code. Here, for example, are check groups, right? Which we've seen in the UI, these folder looking thingies here that you can open and close. All the different types of checks. Here we have a multi-step check, which is um, a Playwright-driven API check, which allows you to combine and chain multiple API requests. Think, complex authentication. Think open banking, right, where you have like 11 steps until you actually get to do what you're trying to do. All of that we can actually drive through a Playwright script, right? So it's not just about the browsers. It's not just about uh, the browser automation. It's also great for more complex UI flows. And on our blog, you can actually find some pretty cool examples of that. Um, so all of these different types of checks, all of the alerting, all of the constructs are now in code here. What does that mean? That's actually quite a departure uh, from a lot of, or it's an entirely different mindset, right? Because here what I'm doing is I am actually uh, again bringing what used to live in a different place. I'm bringing that source of truth into code. I'm bringing it into source control. I'm bringing it into my existing workflows. This might mean, I have a monorepo. Okay, now all of my checkly stuff, right? All of this that you see in front of you actually lives and evolves as part of that repo, right? What does that mean in practice? Well, that means that as I create new checks, let's for example run the checkly CLI here, which is how we do monitoring as code. We also do Terraform and Pulumi, right? But the CLI is where we can take things to the extreme. Well, what I can do here is as I write my checks, I can just test them without even leaving my IDE, right? Which is pretty cool because I tell you, context switching is the bane of my existence. And for everybody that writes more code than I do, I can only imagine. So here, okay, I've tried to run my checks, right? Let's say that I just wrote them from scratch, and hey, one of my checks is failing. Am I going to deploy it to production? Am I going to like wake up somebody in the middle of the night, maybe just because let's say my playwright skills are not top notch? No, I'm gonna fix it. And once I've fixed it, what do? I just keep iterating, right? I just keep going. I just test it again. Is this gonna work? Is this gonna work on Checkly, right? And now, hopefully, if my fix has worked, now we have a fully green suite. Cool. Okay. So you can see how this changes the workflow entirely, right? And by the way, what I can do is, since I'm actually running these checks as tests, what I can do is just, I can add a record flag, for example. Now I'm going to run the whole suite, but I'm actually going to record all of the results onto Checkly. Now this becomes all of a sudden like running an actual test suite, and maybe I can even plug it, and this is what a lot of our customers do. I can even plug it into my CI pipeline, right? And then I can actually stop that pipeline. I can stop changes from going live if any of these checks fails, right? So there's a lot that we can do. And of course, let's switch now to an empty account. We have no checks here, no alert channels, none of that. Of course, what I can do is just run an npx checkly deploy. This might also be happening in my CI pipeline, of course, depends how I want to be set up. And if I refresh here, boom, we have our entire monitoring setup up and running, right? All the checks, all of the alerting, all of the status pages, all of that jazz is all configured and up and running. So yes, now this can finally evolve at a speed that makes sense for today's world, right? Not only that, it's not just about the scaling in terms of how many checks I can create. Some of our customers run tens of thousands, or sorry, They actually have tens of thousands of checks running, right? That means like multiple millions of check executions per day, right? So the scale there is quite interesting. But the what's even more interesting from my end is what scale does this enable within an organization, right? Because let's imagine I'm let me pull up, let's say I'm a developer, right? And I'm trying to, make sure that the application I'm building, or maybe just the microservice, right, that I'm building is functioning, right, from an end user's perspective. Let's go with a browser test, right? Let's say that I want to create that check on Datadog. Let me see if I yeah, okay, I've got my little trusty shortcut here. How does that work, right? Well, this works this way. Let me give this a name, like checkout monitor, something like that. This works in a fully manual way, right? I think the recorder is neat, but again, I have to sort of go in, record this thing. Maybe I click the same thing twice. I'm not I'm not building the best monitor here, but I can sort of go through that procedure. I can add some assertions, right? Oh, first, also you need to click record, right? So I wonder how many people that gets, or if it's just me. Okay, let's just try that once more. Go shopping, click something, get to cart, place the order, and then let's imagine that I've actually added an assertion. I want to save us some time here. I can stop the recording and save, right? So this is cool uh, when I create this, right? But the thing is that we know that the application that we're monitoring is changing every day potentially, right? We're living a world where we want to ship as often as possible. So how do we actually enable folks who are supposed to look after the quality of what they ship to actually own that? Well, monitoring as code allows us to to essentially place realistic expectations on our developers. It allows us to um, give them the keys, right? We can just and this is what I see in a lot of platform teams, a lot of tools teams, centers of excellence, and so on. What they do is they set the best practices at the CLI level, and then they just let their developers self-serve Checkly, right? They just go like, okay, just clone it and knock yourself out. Write your checks, write your tests, run them just from the CLI as we showed a moment ago, right? So with an, for example, an NPX Checkly test, and just iterate fast, right? If you cannot iterate fast when you're creating monitors, how are you supposed to iterate fast when you're building your application? And if even if you're building the application and the monitoring is not evolving fast, then the monitoring becomes useless, right? Your devs get showered with alerts that they stop checking after a while. So it's a big thing. But yeah, so hopefully I've told you a little bit about, why monitoring as code is as revolutionary as we believe it is. Okay, so how do we, looking at Datadog, right? What are our options, right? Let's say that, and Datadog is not Playwright based, right? For those of you who don't know, right? Playwright is its own framework, right? Coming from the testing world, Datadog, when you're creating these tests, as they call them here, which then also can run on a schedule, of course, you're using their own proprietary stuff, right? So it's not like we can easily export a Playwright script. And this is where you might feel a little defeated, like, damn, I was hoping I could get all the goodies, right? Well, truth is, there's some ways that we can leverage some, for example, some AI stuff. Don't be skeptic. There's actually some good stuff in here to bypass that problem, right? And I show you, I'm not gonna do it live because the results are not always they're non-deterministic, and also it takes a while. Actually, I've found I've been using Claude Code, for example, with quite some success, but it still takes a while until it crunches all the data, right? But I have some of the results of my experiments here saved, and some of them are quite interesting, right? Um, so, for example, when we look at, let me just pull up a couple of things, right? When we look at Datadog. Datadog offers us the possibility of just pulling a JSON description of course, using the API, right? It allows us to pull a JSON description that contains pretty much the meat and potatoes of our browser check, right? Of our interaction there with the website. So what we can do, as you can imagine, this sounds like something where an LLM would be quite successful. We can feed that. Um, we can feed that to say Claude Code, for example, right? And we can feed it, let's say, to the augmented version of Claude Code for this purpose, which is the um, the Playwright Claude Code connected with Playwright agents, right? Which can plan, whole test plan, generate the test files and even heal them, right? When some of them are failing when they shouldn't be. So we can leverage all of that to actually just generate uh, scripts that's plain playwright scripts quite easily, right? And that's something that I've done and that has worked quite well. And again, this is just a matter of pulling our existing config and yeah, just pretty much using it. Then I think my export. Oh, I've played around with this stuff too much, folks. So I might not be able to find it in the million of things that I that I experimented with. Oh, this is it actually. So this is a this is where I actually fed my Datadog JSON for the browser check to an LLM, and I got actually a result that works quite well. So this you can actually deploy on Checkly, and it will run from the very first moment. What I've done also, which I encourage you folks to play around with if you haven't yet, is you can get the Playwright agents to just actually use Playwright to explore your website and just create entire test suites for you, right? And don't think that this is necessarily just slop that is gonna create heaps of technical debt. Actually, I was kind of surprised by how good some of the results are. Maybe what we're looking at right now, this is just a small suite that confirms that the site loads, and it's not doing that much, just running a bunch of assertions. Um, this is actually, let me pull up. I have an improved version of that. This is actually stuff that's gonna work. This is stuff that uses mostly the latest APIs, right? We can need, we can add some small improvements to it, but this stuff is gonna actually work. So here, what I've done, and I'm gonna show you, is I've actually gone ahead and I said, you know what? Let me just not do the Datadog export. Let me just create a brand new test plan really for my web shop. And what I've done there is um, just I've had the different agents do their thing, right? And what I received was actually some pretty thorough suites, maybe a little bit verbose for my testing taste, let's say. But actually, what I'm able to do here is just run them successfully, right? So I can do, they're not perfect. There's some that I've left failing also to provide a good example. Um, but what I have done, and then I'm going to show you something that does not involve AI, by the way, that you can use to also generate tests quicker with Playwright, which you can turn into monitors with Checkly. What I've done here is pretty much just selected a subset of suites here, and then with an npx Checkly test, which we very well know, I can actually try and execute them on Checkly. I've chosen a subset, as I said here, right? So I think until number 4, just to keep it, keep it short, keep it simple, and not too dispersive. But here, again, we are using AI-generated specs to test all of the different flows or a lot of the important flows of our demo website. Actually, let me run that with a record so we can actually check the results as well. But this is quite cool because under the hood, what we're using is not Checkly's old school browser checks. We're using Playwright check suites, which means we can actually just feed Checkly entire specs of pure Playwright code, using Playwright's own structure and all of the goodies that come with Playwright to had to just run. You just come with imagine like full suites projects. You're using you're sharing stuff between your checks. You're using all of check or all of Playwright's features, and now you can just add a checkly config file. Sorry, I hope that you folks can read this, even though it's a little bit messy. You just split it up into suites, the whole project, and then you just run it on Checkly, right? Now, this is going to take a little bit to run, right? I think this one is going to be marked as degraded. But hey, we've run a ton of checks here. Let's just look at what happened there. We're actually running quite some good stuff in here, right? So quite some tests, right? We've had some retries. We can dive into the trace. We can use AI again to determine the root cause. So folks, if you're feeling like migrating away to Checkly, would be like a massively daunting thing, actually AI for migrations is pretty sick, honestly. All right, so maybe one last thing that I really want to show you folks is, you're not on board with the whole AI bandwagon. I get it. Can I still, Giovanni, I actually liked the point and click thing. A recorder is good. How come you guys don't have a recorder? Well, we actually do have a recorder. Actually, a recorder is built into Playwright itself, right? Let me just run an Playwright code gen, and then I'm gonna just do my little, if I can type, folks. Typing is hard. Yeah, I can point it to my. Whoops, that got messed up. I can point it to my hotel demo website. Yeah, here I'm launching Playwright code gen. So, wow, my shortcut got super messed up. Let's fix it. What this does is, again, allow us to just click through, and code gen is pretty good for a recorder, folks. I've used a lot over the last 10 years. And this just allows us to click through things, place the order like you're used to. Maybe you want to assert that, but I don't have time. And here we go. We just got the code that we can run. I can just copy that, right? I can add it someplace here. Maybe I could even just, I could cheat a little bit and throw it in there, right? Let's see if we can quickly just run this extra test. Then I promise you that I shut up for a second. It's also important. Yeah, we can run npx. Maybe when we shift to the right folder, we can run an npx checkly test. And now this is going to be picked up. I always forget the record. This is going to picked up and is executed on checkly just like that, right? And I can tell you that's going to work, and that's going to work fine. So yeah, I mean, we've covered a lot of stuff, folks, tonight. I hope I haven't overloaded you too much because we've been running around. We've looked at traces, different types of checks, monitoring as code, migrating from Datadog manually, migrating from Datadog using AI, Playwright agents really quickly. There's a lot of stuff in there. Dan, what do you think? Should we open it up for questions?
Yeah, absolutely. Let's open it up for questions. We actually already have one question, and maybe we could look at it quick. Uh, Asking about alerting and maybe webhook. They have it set up in Datadog to use webhooks and make a nice alerting template. Kind of, yeah, just what does that look like with us?
Yeah, that's a great question, right? You immediately, once you feel that the check functionality is good, right? The first thing you think is, okay, how do I integrate it with what I'm using, right? And there's yeah, I guess there's two sides to that, right? You need to sort of always qualify this based on what you're using. In the most general sense, what I can tell is, we have quite the native integrations, as you can see here. But keep in mind that one of our North Stars, as you can tell from the monitoring as code thing, probably is programmability, right? So we, for example, enable folks to create their own custom webhooks, right? This is something that gets used a lot, honestly. How does that work? You just link it to whatever system you need to hit, right? Again, it's just a webhook, And then you have a lot of different pre-populated environment variables that you can read, and you can build your webhook body just like that, right? So you can add additional pieces of information here. You can add headers, you can add webhook secrets, right? If you need to do a little bit of auth in that sense. So that's part of it. The other part I would say is that Checkly is not trying to like hold on to its data and just prevent you from using that. We're very open in that regard. And that means, for example, if you folks are using Prometheus today, I see so many of our users on Prometheus and Grafana, or anyway somehow basing things around Prometheus. You can just ship all of your metrics to Prometheus and just have, and maybe I should pull up some of our docs there, but uh, essentially check on Checkly, you can just quickly with one click create a scrape endpoint for Prometheus to scrape. Then you pull all of the different metrics there, and you can then use those. For example, if you're driving, alerting through Prometheus or Grafana or something like that, you can actually use the alerting that you've always been using, right? It's just now you've got all of these different metrics coming from Checkly to drive that, right? So we're very flexible in that regard, absolutely. Now the specific suggestions I would give would vary depending on the tool, but this is normally not where we find any friction, honestly.
All right, amazing. Let's see. Do we have any other questions? Gio, I don't see any other questions right now, and I can't even come to think of any because you covered absolutely everything. That was an awesome demo. Thank you everyone for showing up today, and hopefully you can make the successful move from Datadog to Checkly. And thank you again, Gio, because that was amazing. Fired up after that.
Thanks. Yeah, folks, do reach out. We love this stuff, so we're happy to give you a hand there.
All right, thank you all. Have a good day, and happy testing.